Okay, I think we can get started. Good evening, everyone. Thank you so much for joining in today. I welcome you to the first simulation training of Solar Decathlon India. I am Yashima and I'll be moderating today's session. In this webinar, you will learn about how to conduct climate analysis through case studies of work done by experts on net zero buildings. And you will also learn about the fundamentals of DesignBuilder, the data structuring, and PC will also demonstrate the different types of analysis that are possible in DesignBuilder. We will also look at how to represent building geometry for thermal performance analysis and how to review simulation results. Before we begin, I would like to acknowledge the support of the Department of Science and Technology and all our supporters and affiliates of Solar Decathlon India. Today, we have with us two experts from the building industry. First, we have Mansi Parikh, who is a senior sustainability consultant working in the field of sustainable design. She has key qualifications in the field of passive designing, low energy cooling and HVAC systems, lighting and daylighting design. She has worked on various projects with goals leading to net zero energy, water and waste. We also have with us PC Thomas today. PC is the founding director of Team Catalyst and also an adjunct professor at the University of Sydney. He specializes in integrated building design, using simulation tools to assist in the design and delivery of sustainable buildings, in particular in predicting the performance of mechanical services. He has a master's degree in mechanical engineering, 30 years of consulting, research, and teaching experience in sustainable buildings, building energy simulation, energy auditing, energy efficiency in building, and solar energy. PC is talking to us from Australia, so it is late evening for him right now. Hi, Mansi, and hi, PC.
Hello, hi, Yashima. Hello, everyone.
All right, and over to you, Mansi. We'll have your session first, followed by PC session today.
Perfect.
So
I'll
you can
share my
just
screen.
share your slides.
Yeah. Can you all see my screen?
Yep. Yes, Mansi, it's visible.
Okay, all right. So in today's discussion, we are going to discuss about why climate analysis. So why it is important, parameters looking into climate analysis, like air temperature, relative humidity, irradiation, wind speed, wind direction, and ground temperatures, and how that can be used into designing a particular building. So first we'll look into why climate analysis is important. Okay, so the first thing first is energy efficient building needs cooling. So looking into tropical climate like India, we require cooling across a couple of months across a year. So passive, if we design building passively, then we'll be able to provide free cooling or heating strategies to reduce energy consumption. For this, climate analysis helped me for this particular project in deciding which exact passive design strategies to go with during the design stage, like massing, shading, natural ventilation, daylighting, etc. So, so passive, I would say that for net zero building, passive design strategies are the first way and the first step towards the energy efficient building design. So I'll give you a brief about a project which we worked on. So in this presentation series, we'll be talking about college campus project, which was in Sonipet. This again is a real-time project, which I was working on, which is a net zero campus. This is designed to be a net zero campus. So in this map on the left, you can see that major climate divisions across the country, okay, which are hot and dry, warm and humid, cold and cold, composite. So composite climates are where we observe both extreme winters as well as summers, and temperate, which are moderate kind of climate, which generally have a comfortable range of temperatures across the year, like Bangalore or Pune. So Sonipet here, which is in Haryana, falls under the composite climate conditions, which has both extreme summers as well as extreme winters. So where the summer temperatures goes around 44 degrees and the lowest recorded temperatures are 4 degrees in the winter time. So this is always a tricky temperatures to work with and tricky climate to work with when designing for passive design strategies. Okay, so in this chart, we are going to talk about air temperature and relative humidity. So in this chart, air temperature is shown in in the red line for hours across the year from January to December, and relative humidity is depicted in blue. And the gray band here shows the thermal comfort band based on India model for thermal comfort, which varies across the year for various kind of building. For naturally ventilated buildings, the thermal comfort band is different. For air conditioned building, the thermal comfort band is different. So however, these blue lines are your humidity across the year, and the red ones are dry bulb temperature. So Yashima, can we have the first poll question?
Yep. I will launch the first question for today.
Yes.
So the question is, as per the graph shown, which months can evaporative cooling be used as a passive strategy? And there are 4 options. You can select one of those based on your understanding.
So while this question is running, I would like to say evaporative cooling works on the strategy where we are providing air to cool down the temperatures. So as you can see in this graph, relative humidity and dry bulb temperatures are inversely proportional. So if you look into it closely, probably you'll be able to understand.
Yep. A lot of responses coming in, and it will be good to have more engagement. So everyone, please open the polls on your screen and answer the question. All right, I will now end the poll. Okay, here are our results, Mansi.
Wow. So we have all the answers. Okay, there are a couple of people who have said in winters, monsoons, summers, but the correct answer here is, I think that has maximum percentage again, 66% people have said that it is between April to June, and that is the correct answer. Because this happens, so as I told earlier, right, humidity and dry bulb temperature or your ambient temperatures are inversely proportional as per the graph. So in this particular graph, so that would happen. So whenever the temperatures are, so what happens in the months of April to June, that your temperatures are quite high. However, your humidity is quite less. As you can see here, you can see it's almost less than 40% across the day. So what happens is we'll be able to provide misting, okay, and then we'll be able to reduce the dry bulb temperature here. So as you can see, for this particular climate, we had 33% of the hours across the years which were comfortable. So discomfort is on the left from the month of October to March due to low temperatures and high humidity, and in summer months due to high temperature and low humidity, and monsoon due to both high temperatures and high humidity. So basically this graph shows, and based on this, we deployed natural ventilation strategy in monsoon spaces to reduce discomfort hours. However, active cooling was provided and required for specifically in summer months. So that to this strategy of evaporative cooling system design, where we were able to do the passive cooling for that particular months. So, okay. So here, this particular diagram shows the sun path for a sonipet. So sun path is important for any shading design, So the sun path shows apparent position of sun from each hour across the year. And these lines in blue shows hour of the year and sunrise to sunset time, sunset. And line in red shows months from December, which is in bottom, here to June, which is in the top. So this is sort of the, based on this, you'll be able to see the position, and based on this, we'll be able to design shading system. So designing for shading, you could look into the Solar Decathlon India modules for the details for the same. So in this particular diagram, represent the horizon, which is divided into equal parts. The color from blue to red shows intensity of solar radiation falling on each of these directions. So this is basically west, east, north, and south. These are three particular diagrams which shows solar radiation in winter months from November to February, summer, which is March to June, and monsoon, which is July to October. So this charts actually helps us in designing for shading. So we have a question coming up. So Yashima, can you launch the polls, please? The second question.
Yeah. Yes. All right. Our second question today is, as per irradiation graphs shown, shading for windows will be required for which season? And the options are summer, winter, monsoon, or all of them. All right. A lot of participants responding here.
For passive design buildings, Yashma, we do require a couple of things. So for thermal comfort and for reducing your EPI and consumption, the WWR is very tricky. So WWR is your window to wall area ratio.
Right.
Then your envelope, like glazing and wall systems, that becomes very critical. So
yeah, also Mansi, just one question here. As people, our participants answer here, can you also talk a little bit about the kind of tools you use to develop these?
Sure.
Yeah.
Images. Yeah. So there are a couple of tools which we can use here. What I have used is the Grasshopper. So the Grasshopper is a plugin called Ladybug. So based on, I have used these to get the customized outputs. However, there are other plugins which are particularly easy and which the students can definitely use. That is Climate Consultant. Okay, Climate Consultant, I believe, is free to use. There is no license involved in the same. So yeah, and very simple to use that particular software. So I would definitely recommend students to start looking into Climate Consultant.
Right. All right. I will now end the poll so that all of us can look at answers. Yeah, Mansi, here are the answers.
Wow, again. So I'll tell you about the answers. So 36% people have said that summer is the month where we would require the shading. And then there are a couple of people, 58% of people has responded saying that, we would require shading in all these seasons. So the answer here is that answer D, which is, as you can see, we would require shading in all the months, A, B, and C, so across the year, because, okay, as you can see, what happens is irradiation is higher across the year. So all red, okay, as you can see on your screens, all reds. So that is irradiation more than 25 kWh per meter square is happening across the year. You can see that in winter. You can see that in summer, and you can also see the same in monsoon season. So you would require to shade your windows not only for summer sun, okay, but high intensity winter sun as well as monsoon sun. So I would say the answer here, which is correct, is, we would require shading in all of these months. And, for this particular project, what we did was there were a couple of strategies which we incorporated looking into these irradiation charts where we limited the window to wall area ratio to less than 40%. We provided U values. A lot of studies was again done to understand what the U value should be provided. We'll be talking about the same in coming webinars. But however, those U values or SHGC of the glazing, that all depends on the irradiation of a particular place. And on a particular surface. Okay, so irradiation analysis is critical. So hence shading was designed to protect from all of these seasons, and we designed shading for 9 a.m. To 4 p.m. from March to October, and for 11 to 2 from November to February. So as you can see, yeah, high intensity winter sun, and then we did for high intensity monsoon sun. One important factor to note here was, based on this, we suggested client to provide north, the building in north-south direction. So longer axis across north-south direction, as you can see from these diagram that, there is high intensity sun in south direction, but it is easier to shade the southern sun. But it is always trickier to shade your windows in west and east direction, which you can see is always higher across the year at a lower angle. So what happens here, west and east direction sun are at a particular lower angles. However, the sun azimuth angle at south is quite high. So it would be always easier to shade this. And providing windows in north is most beneficial because you can do with very minimal shading. So these all strategies can be informed through climate analysis for irradiation. So this chart represents wind direction and speed specifically. And as you can see, the wind speed, as the blue being lower. So this charts go from blue to red. This shows both direction as well as speed. And as you can see, the blue being the lowest amount of wind speed to red being the highest amount of the wind speed. So we have one more question, Kamika. Yashima, can you launch the polls?
Yes. All right. Our next question is, for naturally ventilating the space in monsoon season, operable windows should be provided in which direction? Should they be north or should they be west?
So, what you would have while you're answering this question, I would like to say that what you have felt is we humans generally perceive thermal comfort, feel more comfortable with high temperatures with elevated wind speeds. So what happens when you are out in summer? Okay, when your temperatures are quite high, humidity is quite high. But however, if there is a pleasant wind coming on when it touches your skin, you feel a little bit colder, because that what happens at your skin level is evaporative cooling. So sweat, at times what happens is we feel cool because we are sweating. So that again is a principle of evaporative cooling. And however, human perceive more thermally comfortable when there is a adequate amount of wind speed. So wind again is a critical component to design with, and always a little bit trickier.
Okay, we've got a lot of people responding to the question. I will now end the poll so that all of us can look at the results. All right, here are the results, Mansi.
Okay, perfect. So 26% respondents has said it's north, and 74% respondent has said it's west, and the correct answer is west. Okay, why? Because what happens is that as you can see in this particular charts, that wind direction here was west. So here you can see that the wind direction as well as wind speed is both high in west direction. So the correct answer is west. So for this particular project, we oriented our windows towards west direction. So, designing windows does not guarantee the wind flow inside the space. There are a couple of other factors which plays an important role while designing for natural ventilation. So those factors being wind direction and wind flow. Both should be considered during designing for naturally ventilated spaces. Also, wind pressure is a critical component. So in this project, what we did was we cross-ventilated the corridors and the classrooms for specifically the monsoon months. Because what happens in monsoon, we have higher temperatures and we have higher humidity. So we wanted to ventilate these particular spaces for monsoon months. So we ensured that wind flow had an inlet as well as outlet for better flushing of air in the particular space. So windows were both placed in west, east, and northwest direction to improve the wind flow in a space. So, we had to do a couple of studies. So we did CFD studies and detailed window design studies to ensure the wind flow in a space, and checked for parameters like thermal comfort hours in our natural ventilation models, in the energy models which we did. We will also cover natural ventilation in our upcoming webinars. So the next parameter which we are going to see is ground temperature. So this chart shows ground temperature. So temperature at ground level below the surface. The line in blue actually shows the ambient temperature, and the line in yellow shows the ground temperature at the depth of 4 meters below the ground surface levels. Yashima, can we launch the poll now?
Yep, Mansi. Okay, our last poll for today is, the question is, can earth air tunnels be deployed as passive cooling strategies from March to June? And the options are yes or no.
Yeah, this one is simple. Okay, so I would like to tell what earth air tunnels would mean and how they work. So earth air tunnels works where pipes are laid below ground at certain depth. So here, say at 4 meter depth, and the air is blown through these pipes at times actively, or there is an inlet for the air. And then when the pipes which are in direct contact with the ground cools or heats this air through conduction. So at times, earth air tunnels can be used for both heating as well as cooling in particular spaces.
Yeah. Okay. We've got a lot of responses, and I will now end the poll. All right. Here are our answers, Mansi.
Wow, this is maximum number of people has given the correct answer. That is with 89% of people has said yes. And the answer is correct. So what happens here is that as you can see in the chart, the difference between the dry bulb temperature and the ground temperature is almost 8 to 10 degrees for say April to June. Okay, then again we can see the temperature difference here during the winter months as well. So across the year is almost 4 to 5 degrees delta, average for more than 5 degrees of delta across the year. So earth air tunnel can be used in say specifically summer months for cooling, and also it can be used for winter months for heating. Say it can be used in January or December where temperatures are almost 12 degrees. Then this can be used as a strategy for heating to up to almost 22 degrees. However, we did this analysis, but this was a system which we didn't deploy in our project, which I was working on, because since this was a little bit expensive and the client didn't want to pursue that forward. So yeah. So that's it. Yashima, should I cover the deliverables parts or should we take questions?
I think let's take questions, Mansi. We have a few, the deliverables bit was covered in the last webinar, so our participants can definitely look at that recording. Yeah. All right. So we have a few questions coming in. One is how are people using Rhino software? Are they purchasing it or are they using the pirated version? I would say people are purchasing it, Mansi. I think you also would have the purchased version for Rhino, right?
Absolutely. I do have a purchase version for Rhino.
Yeah, yeah. And also we provide not climate consultant, I'm sorry. We provide another plugin for which also you will need Rhino as the software. Only then you can use that plugin.
Climate Studio.
Yeah, Climate Studio. Thanks, Prasad. Okay. Next question. Since the city is in Haryana, the project that you showed, um, does it not require that we allow, will it not require that we allow winter sun and block summer sun? So shading device should be designed based on seasonal or annual radiation level. Mansi?
Yeah, so I think so in this particular project we accounted for both. So heating would be required in winter months. However, shading would be required for summer months. So we would require shading in both the. So whenever we're designing for shading, we should not do it annually. We should look into the seasonal variation. So what strategy we deployed was we allowed the winter sun to come in, and then we blocked the summer sun. So specifically for north and the southern direction, what we did, we had these louvers. During the summer sun, we would angle it at a particular degree to block the summer sun, and then we'll be able to open it at a particular degree during the winter timings. So yeah, it is important to look into the seasonal variation and design the shading devices accordingly.
Yeah. Yeah. All right. Another question, how to get data for all these charts? For example, wind speed and solar radiation. Where do we get the base data from? Mansi, where do you get your data from? I mean, I know there is one website, climate1.building.org, which gives you the weather files, but do you know of any other resources that you use?
Yeah, so there are a couple of, I generally I get the data from climatebuilding.org. All my data files are there. Those are the most recent ones, EPW. That's what that's the reason why I use it. But however, there are a couple of other sources like Energy Plus website, which would give you data, weather data across the year. So one could look into that.
Yeah, and I've also shared the link to the website where you can download the EPW files. It gives you, the website gives you files for multiple cities globally. So you can go in the India section and, if your project is in India, and look at the cities, the different cities that are available. It is a good bank of, it has a good bank of multiple kind of cities. So, yeah. Can you talk about the plugins that you've used for wind study? I'm guessing it is Grasshopper, but you can.
Yeah, so the plugin which for plugins which I used for all of these studies was Grasshopper. For the plots, what I did for a couple of plots, what I did, I got the data in Excel and post-process it, because that's the most easiest one for me to do, because I like the pretty images. So and the graphs which are easy to look into and very much readable. So however, what for students I would rather suggest, start looking into Climate Consultant, because that is quite easy to look into and very, I think, quite easy to look into. Okay, so
Yashima, I have a question from Mansi.
Yeah.
Yeah.
So earlier question said that for Haryana, the winter sun should be let in, and Mansi agreed to that. But in the poll question, you said that we should be shading all years. The correct answer was shade all hours. Can you clarify for the attendees how you're distinguishing between the two?
Correct. So that depends on the intensity of the sun. So the way we have to look into is we have to look into the irradiation across the year. So can I go back to that chart, and probably that would be easier to explain?
Yeah.
So, okay, I'm going back to these charts. Okay, so intensity of the sun depends on the direction, and it varies across the time. So what we have to do is we have to place your sun path over the top of it, and we have to see. So what I did was shade from 9 a.m. to 4 p.m., from March to October. And from November to February, I shaded from 11 a.m. to 2 p.m. So those are the winter months, correct? November to February. So because the solar radiation is highest during these months, from 11 a.m. to 2 p.m. So you block those months in. However, morning sun is quite pleasant. From 9 to 11, you'll be able to get that sun in. So yeah, you have to shade. I would say you have to block in a way. But however, if you want to allow it, then there is a window for which you'll be able to do that.
Yeah.
Thanks.
Prasad? All right. Okay, I think we have a few questions, but we'll move on to PC session for now, and then take all questions towards the end of the session. Yeah.
Sure.
So Mansi, if you can stop sharing, and PC can start sharing the screen. Hi, PC.
Sure thing. Yashima, how many minutes do you want me to share for?
I think we can go on for 25 to 30 minutes.
Okay.
Yeah.
So welcome everybody. So what I want to just cover in those 20 minutes is you have access to a tool called DesignBuilder. And so I just want to give you a few ideas of what DesignBuilder will allow you to do. Okay. So to get a quick idea of what DesignBuilder is, you have a couple of websites that you can go to, right? There is a website which we maintain. We are the Australian and Indian reseller. We're exclusively selling the products into Australia and India. And if you look here on the home page, you'll find a little description of what DesignBuilder is. And typically, the easiest way to say this is that it's a graphic user interface for some what we call global gold standard open source simulation engines. So there is a simulation engine called Energy Plus, which does calculations for energy, thermal comfort, natural ventilation, air conditioning systems, all of those things you can use Energy Plus for. And there's another one called Radiance, and Radiance is very good for daylighting. Okay, that's down here, you can see that. Again, that's an open source engine. Both of these were developed in the US, funded initially by the US government. Energy Plus is still maintained by the US government. Radiance right now is a community supported software, but there is some thinking that IBIPSA, which is the International Building Performance Simulation Association, might get back into trying to maintain it. Okay. So I'll leave it at that. I'll get you to read that and maybe look at this video that's here. Another one website that you can go to is the UK website. They're the parent company for DesignBuilder. And the reason you might want to go there is there's a whole series of tutorials and webinars that are available. You will need to create an account, but the account is free, and you should be able to get yourself, I don't know what I did there, but I think I changed the screen resolution. Hold on a minute. Let me just get this back to where I can see it properly. Okay. All right, that's better. Okay, so here there's a series of introductory tutorials. So when you start using DesignBuilder, in addition to the webinars that we conduct, you can find data for those kinds of things here. Okay. So what I'll do in the next 10 minutes is I will share some screenshots from a lecture for which you have got the link to. And if you listen to the lecture, it was done for a university, and it's about digital computational architecture. All right. So I'll just take a few screenshots. I won't share all the whole lecture, but it starts by looking at a case study in Sydney, which is in Australia. So some things are a little bit weird, but it does give you quite a good idea of what all can be done, right? Now, Mansi was talking about climate consultant. Here is a weather snapshot of Sydney from climate consultant. So you can see it gives you quite a lot of data which you can look at. And that's the weather file that we use to run the energy simulation. It's called an EPW file, which is an energy plus weather file. I'm sure you've come across that before. Okay, so the project that we are talking about is a renovation of a house residence, and this back portion of this house was renovated, and this is what it looked like before the renovation. It was quite an old building, and as you know, in most Western countries, buildings are made of timber rather than brick. You may have a brick covering, but that's not really a structural covering in most houses. Okay, it's timber, and in this case, there was weatherboard there. And what was done was there was a design. So, typically you want an architect or somebody with architectural training to do the design. And as Mansi was saying, you look at climate and so on. So that design was then modeled. So this is the DesignBuilder model, right? So we are looking at this red rectangular bit that's inside this red circle. That's the one that was being remodeled. That was modeled as the living space. And as you can see, there's a whole series of elements that are in the model. And on this wall, which is facing 270 degrees, which is west, there are two windows, and those two windows are represented over here, as you can see. Okay. So when you build your models, whatever creates a shading from the sun, you have to model them using something called a component block. And those are these purple shades here. And they're really privacy screens so that the neighbors can't look into this building. Now, within DesignBuilder, you can do daylight analysis. So this is an illuminance analysis, which is a static analysis done for 1 hour in overcast sky. And because it's an overcast sky, it doesn't matter what time of the day or the year it is. We're only looking at diffuse light. Okay, so by looking at this, you could kind of say that, for example, the kitchen has got one window. The kitchen is being extended. There is one window here. And behind the window, there is some light, but you can see this part of the kitchen is dark. And because of that, you can take a design decision to put a solar sky dome, which allows light to come into that part of the kitchen. So you can see it changes the way the space feels. And you can use daylighting analysis to do that. Okay, here is another kind of daylighting analysis. This is an annual daylighting analysis. It's called UDI, the Useful Daylight Index, and that allows you to specify a minimum daylight factor or daylight level and the maximum daylight level. It crunches through every hour when daylight is available, and it tells you what percentage of the time daylight is within that limit. So it's neither too low nor too high. Too high means glare, too low means not enough light. Okay, so just to give you an idea, between these two windows, you're getting the most amount of useful daylight. If you look at the previous graph, you will see that you're getting, if you looked at it directly using illuminance, you can see that you're getting the most amount of light just behind the windows. Okay, but this thing is telling you a different picture, that yes, you might get a lot of light, but useful daylight across the year is actually in between those windows. So you can do that with DesignBuilder. Another thing you can do is you can do the sort of solar dome analysis that Mansi was talking about using DesignBuilder. Once you've got the model built in, those are those two sun shading wing walls there, privacy screens I was talking about. Now, Remember, this is Sydney. It's in the southern hemisphere. So July is winter for us. That's why the sun is low in the sky in July here. In Delhi, in India, in June, July, the sun will be right on the top. Everything is flipped around, okay? And you can see that as you do the runs. So in this case, winter morning. Yeah, this is east. This is winter morning. You can see the sun is coming through these windows on the top here, and it is creating a patch of sunlight on the ground. Now there is a photograph post-construction, so you can see that same patch of light on the ground. And if you go back and compare it with the model, you can see that patch is very accurate. So these models are very good, okay? So I will, that's another kind of analysis you can do, right? Then the kind of analysis that you want to think about is if you do things like this, that is, if you put insulation, in this case, we're putting insulation under the floor. Here there is insulation in the walls. That's insulation on the ceiling. It's being covered up by a plasterboard, a gyprock board, we call it here, especially for ceilings. And you can see there is a silver foil over there. So these are all different parts of the construction, and it is representing this kind of construction. Okay, so there is a metal deck on the outside, a piece of insulation and the silver foil there, double roof battens, then insulation, and then that ceiling gypboard that I was talking to you about. Similarly, you can see that you can represent all kinds of walls. Now, typically in India, this would be brick and plaster. In Australia, we're using on the outside a timber board called WeatherTex. There is an air gap, there is insulation, there is a plasterboard lining on the inside, and there are wooden studs that connect these two parts of the wall. You can show all the layers that your wall is made up of. Each one of these layers comes with a series of material properties. So conductivity, specificity, density, and so on. And there are properties for daylight calculation also included. There are many materials included within DesignBuilder, and it will calculate for you what is the U value or the R value, which is U value is thermal transmittance, R value is the inverse of that, resistance to heat flow. It will calculate that for you for this construction that we were talking about, okay? And of course, there's an image to help you. Now you can run many kinds of simulations. In the residential one, we ran what is called a free running simulation. That is, there's no heating and cooling. This is a winter month, so we had kept all the windows closed so the heat won't escape. And what is this telling me? It's telling me that when the outside temperature is almost 0 degrees here, 2 or 3 degrees, the room without any heating and cooling is not dropping below about 12 or 13 degrees. So that is what we are able to do without any heating and cooling. And then you can work that out. All these numbers are available in CSV, comma separated variable files. You can put them into Excel files. You can do all kinds of analysis with it. So this particular room is used in the daytime. So what we can see is if you look at the daytime hours, and if you consider that comfortable hours are between 19 and 26, then I can say that about half the time, this space is comfortable without heating and cooling. But it means that in winter, half the time I need heating as well, okay? So that was winter. Now, if you look at summer, you can see now the sun is quite high in the sky. And now you're getting sun coming in from the western windows when I don't need them. So you can see here, there's this patch of sunlight on the floor. Now, what happens? I'm going to show you results for 1 week from 2 simulation runs. Okay, so let's take it carefully. This green line is the outside temperature. Now, Sydney is a fairly moderate climate, so even when we say it's summer, we hardly go beyond 35 degrees. So this day is 32 degrees, and there's probably one other day which is close to 30 degrees here. We do get a couple of days of 40 degrees, but that's quite unusual, okay? But what happens is all that sun comes in through the windows, and this is the west-facing window. You can see the sun. As soon as it swings over to the west, you get a huge burst of solar radiation coming through the windows. Because you get this solar radiation coming through the windows, the mean radiant temperature, that's the temperature you feel. Sometimes you call it globe temperature. That globe temperature is quite high, even though the outside is quite mild, okay? So what do you need to do? Well, one of the decisions that you can do is do what Mansi said. Have a series of louvers or blinds, or if you want to call them chicks in India, where you can cut out the solar radiation from the window, which is what this blue line is, which is the second simulation that we ran, okay? And because of being able to cut out the solar radiation, that zone mean radiant temperature dropped from 40 degrees to 32 degrees. So that's 8 degrees of temperature that was lowered by just shading the solar radiation coming through the windows, okay? And therefore you can see this temperature is now much cooler than it was without those blinds. Okay, so in this case, we had these Venetian louvered blinds, which are adjustable. They're motorized. You can lift them up. You can change the angle. You can do all of that stuff. Okay. Now, another couple of things what you can do with DesignBuilder is you can look at natural ventilation because it's got what's called a bulk flow network analyzer. So if you look at this 1 hour, January 29th, 4 o'clock in the evening, there are two arrowheads. The black arrowhead shows you which direction north is, and for that hour, the red arrow shows you where the wind is coming from, okay? And there's a particular reason why I chose this graph. See, typically when you're looking at natural ventilation analysis in any textbook, you will see that the arrows are such that the air comes in from the lower windows and leaves from the upper windows. This is exactly the opposite. Air is coming in from the higher windows and leaving from the bottom. And that's because the direction of the wind, okay? And that's what Mansi was showing you in those weather graphs. So every hour will be different. If I look at another hour, because the wind direction is so different, you can see here, air is coming in through this big glass door. I've got about 25% of that door open and 25% of these windows open. You can control all of that within DesignBuilder, and then it will tell you how much ventilation is taking place. Now, this is not CFD analysis. This is airflow analysis. Okay, so it gives you a bulk idea of how much air can be moved through a space. Now, using that, you can do exactly what we did for winter. In this case, you can talk about how many hours are comfortable or not. You can decide what is comfortable temperatures or not. And in this case, if I look at the air temperature, I can say that the percentage of uncomfortable hours in the daytime is only 6%. But if I look at the radiant temperature instead of the air temperature, that story changes. Okay, now 44% of those hours are uncomfortable. So I have to think about that. Okay, so those are the sort of things you can do within DesignBuilder. Now, this is what it used to look like. This is what it is after that remodeling. Now, one other thing that I want to show you, which in India, we don't consider that much at all. Okay, here is a 2-story family house in a part of Sydney called Western Sydney. Western Sydney, the climate is very different from eastern Sydney, which is near the coast. This is quite 30, 40 kilometers inland. And this is the visual representation, a rendered representation of the building. And this view allows you to check that you have put the correct materials in the right places. So for example, I've got two kinds of windows. So the first floor window is different from the ground floor windows. And by looking at the colors which I set up, I can easily see what's going on. Okay. And so on. I won't bore you with it. But one of the things that we have found, and this is well known around the world, is in winter, heating is very dependent on how much air leakage is there in your house. And around the world, there's a thing called a blower door test, which allows you to determine how much leakage is happening. So if you test at 50 Pascal pressure differential in a blower door test, a typical house in Australia, which is not very well built, leaks at 15 times an hour. That means the entire volume of the air is changed 15 times in 1 hour in that 50 Pascal pressure differential, which is like a stiff breeze. It's like a 30 kilometer an hour breeze. Okay. If you do things so that the leakage reduces, then you can start to lower your heating energy use. Okay. But when you make the house really tight, you have a problem. Okay. And this is only useful in cold climates. If it's too tight, then you start to reduce the change of oxygen. So you have higher CO2 concentrations. You have all the moisture also trapped inside the house. That's why in places like Germany and Sweden and all, they then start to use something called a mechanical ventilation system with a heat recovery ventilator. Now, this may not be a good option for most of India, okay? But wherever it's really cold, and it's cold all the way through, you have to start thinking about how much your air is leaking. Now, if you put that mechanical ventilation system with a heat recovery, you can reduce your heating energy use across the year even more, to the point where you can almost get rid of it. So in Sydney, by doing that, we found that we could reduce the heating by 3/4, and you could halve the size of the heating system that was there. Okay. And that's what you can do in a residential type project. I want to show you a couple of pictures on what you can do with with advanced air conditioning systems. So I'm just going to show you that I've given you a link where, again, there's a paper that we wrote. So in this case, the building geometry is pretty simple. You can see that it's just a big tower building with a very simple facade. But what we did was we first plotted the heating requirement, the cooling requirement. And again, this is for Sydney. This for us is winter. So June, July, August is winter. For India, of course, it's opposite. I'll show you a graph for Delhi in a minute. But just remember, this is cooling. And the red graph in the back is the heating. So in winter, this is heating. In summer, that is cooling, right? You can model very complex air conditioning systems. So here is a variable air volume system. It has got 1, 2, 3, 4, 5 air handling units. Each air handling unit has got a cooling coil, a heating coil, a fan. There's a reheat coil to reheat the temperature inside the zones. There's a whole bunch of zones that this AHU is connected to. It's represented by one zone, but if you double click on that, it will show you all the zones that are connected to that air handling unit. So the VAV box is here. The variable air volume box is here. That is supplied cold water by a set of chillers. There are 3 chillers here in this one. Those chillers are water-cooled chillers. So you've got 2 cooling towers that cool this chiller, right? And we use a boiler for heating. So it's a gas-fired boiler. There are heating coils in the AHU, air handling unit, and in the variable air volume box in this design. In other designs, it would be different, okay? Here's another one. This is called a passive chilled beam system. Okay. Again, we have the 3 chillers. Again, you have an air handler, but the air handler separately puts out fresh air that is conditioned, and the chill beam, the passive chill beam, is on the ceiling over there. Okay, and there are controllers and all kinds of things going on here. In this case, there is a heat exchanger because the 2 streams of cooling need to be provided at 2 different temperatures. The air temperature is different from the beam temperature, and you need to learn about why chill beam systems are designed like that, where once you know the theory, you can model the practical. Okay. Here's another one. This is an underfloor air distribution system. And what that happens is, it's not well represented in the diagram, but basically what happens is that you supply the air under the floor, and you supply air at about 18 or 19 degrees centigrade, because if you supplied it any colder than that, then you will freeze people's ankles. Okay. And then this is a completely different kind of air conditioning system, but that's, you can model that as well. Now, the paper that we wrote basically compared all of that. If you read through that paper, you will see there's a lot of discussion that is provided to you on that. So just 2 more minutes, I will just show you this. When you model a building, like here you go. I've got a building here. You have the overall building. Dark gray is opaque, light gray is windows, pink is shading, right? If I want to, I can turn on these visualization modes. That one tells me what materials have been put on the building. And if I go to the rendered view, then you can see how the sun path works in this building. Okay. So you can, and I think I've got Delhi here. So here now, you can see here that July, June, July, May, these are now summer months. The sun is very high in the sky. Okay. And January and December are winter. The sun is quite low in the sky. Okay. Now, while Mansi was presenting, I did a quick run, and I just wanted to show you how you can see results in that come out of Energy Plus. Energy Plus, as I said, is the engine that sits behind. We have a program called Results Viewer, which is free to download and use. And with that, I ran this model that we were talking about just now. So this is the heat output or extraction that the chilled water system needs to do in Delhi for that building. Okay, and now you can see this is June, July, August. This is the summer months. These are the days when there are the highest cooling loads. I've run it only for Monday to Friday. So after every 5 days, there's a couple of days break in between because it's an office building and everything is shut down. But you can see that early morning, as soon as you start up the chiller, is when you get this peak. And then later on, you might get a peak in the afternoon as well. So that depends on how the building is used. Now, if I look at the boiler, you can see that this is the heating thermal requirement. So this is the heating that needs to be provided by the boiler system. Okay. I can do other things. I can look at what is the, here we go. I want to know what's the air temperature outside. So what is the Delhi air temperature? So in these months or in these days and weeks, you can see here, that's a pretty high temperature day. Okay, so around there, the temperature is 44 degrees. And at that point, the cooling load for this building is 2,000, I should say, kilowatts. Okay, and you can work out all of those things. You can plot all those things and have a look at it. You can look at air temperatures. Let me see if I've got another quick graph. 2 more minutes and I'll be done. Okay, so just to show you this, here's another model that we did. So in this building, I modeled a top floor, a typical middle floor, and a ground floor. I was looking for these things: annual cooling demand, heating demand, air temperature, mean radiant temperature, PMV for comfort. Okay, I apologize, the results I'm showing you are for Australia, so you still get that weird thing happening where June, July is winter, but it gives you an idea. So I've divided that typical floor into a series of zones, and air conditioning engineers will separate zones into perimeter zones and internal zones and unconditioned zones. Okay. This is an open plan office. These yellow walls don't exist. Okay. The architect does not have these walls, but the air conditioning engineer puts these zones to understand how to air condition these areas which are close to the outside, what we call perimeter zones. Okay. Now, if I look at the cooling and heating required for the whole building, this is cooling, this is heating, and here is the air temperature. And you can see here, Sydney has got 140-degree day, or a couple more in this instance. Okay. You can look at things like this. So for one particular day, I'm looking at things. All right. This green line is the zone temperature. And you can see the air conditioner is set at 23.5. And by about 2 o'clock, the room is being held at 23.5 degrees by the air conditioner. That is the air temperature. Okay. This is the temperature outside. Okay. So you can see here it has gone up to about 31 degrees centigrade on that day. But that mean radiant temperature, the globe temperature, that starts to climb in the afternoon. And you can see here it is getting to about 38 degrees centigrade. So this is, while the air temperature that the air conditioner is maintaining is 23.5, what you might feel might be significantly higher. That depends on the quality of the building fabric, the roof load, all those things. And you can measure that by looking here. I know this is a west-facing zone. Why do I know that? Because the solar radiation increases afternoon in that zone. And that's the time when the predicted mean load, the thermal comfort, gets out of range. When it goes beyond +1, people start to feel uncomfortable. So if you look at that, this is DesignBuilder's output, or Energy Plus output, using that results viewer. This is the outside air temperature in green. For the zone is being maintained around 23.5, 24 degrees, and that's the blue little triangles and lines that you can see here. But the radiant temperature is this red. So you can see while the blue is being maintained in the temperature, the air conditioner is working perfectly, what you might feel might be quite different. And because of that, now I've plotted you the predicted mean load, or the thermal comfort, in two zones. One is this center zone, north, which is the internal zone. So if I go back to the floor plate, it's one of these ones, this internal zone. It doesn't see the sun directly. Okay. That zone manages to keep the predicted mean load within that +1. You can barely ever see it going outside +1. This zone is a perimeter zone that faces east and north. And here you can see the PMV rises above 1 quite a lot. And it might be strange, but you might get the most discomfort, not in the hottest month or the coldest month, but in those middle months, the ones that Mansi was telling you about. Okay. I'm going to leave it at that. Those are all things you can do in DesignBuilder. You will have to work pretty hard to sort of understand how to do all of that, but it is all possible within that software. Okay. Yashima, you want to take over?
Yeah, thanks. So, in addition to what PC said, I'll also like to mention that we have given access to Climate Consultant on the learning management system. That's the tool that Mansi was also speaking about. It's a free tool. The link to download it is in your learning management system. You can access it from there. And once you put in your EPW file in that tool, you get all these parameters, dry bulb temperature, globe temperature, radiation, wind speed, etc. All those climate related questions will be answered or can be answered through Climate Consultant. Once you get into your building side, I think going into Design Builder would be helpful after that. Am I right, PC?
Yes, that's right.
Yeah. All right. Thanks, PC. I will now take a few questions. One question that we've got is, where can we find tutorials on Design Builder on how to work with simple block models? Is it possible for you to share some tutorials of some sessions that you've done, PC, right now? You can put it in the chat, maybe for our participants.
Actually, the best might be, Yashima, if you want to give them access to the webinars we ran last time.
Okay, sure.
That's
We can do that.
probably, yeah, that's probably the best. On the first one, we started to do geometry. And what I can do is, there is an exercise we developed for architecture students at the University of Sydney here. So we can give you that exercise and people can work through it. And it gives you quite a good idea of how to do fairly complex models. A basic shoebox block model is very simple in DesignBuilder. You simply draw a rectangle and it builds the rest. It's very, very easy to do. Okay. It'll take you 5 minutes to do that.
Sure. So PC, if you can send over the exercise and we can share it with the participants after that. Yeah. And the recordings, the ones that PC mentioned, are available on the learning management system again. So you can look at those recordings as well. All right. Another question. Mansi, this one's for you. How are you able to relate time of the day with the irradiation value and solar angles?
Sure. So the way you have to do it is simple. What you have to do is, over the irradiation results, the irradiation dome results, overlay a sun path on the same, not sun. So hours of the day part of the sun path. So if I can quickly share you my screen, I'll exactly. 1 moment. I'll share my screen. Okay, can you see my screen?
Yeah, it's visible now. Yeah.
Yeah. So what happens here is, if we, overlay these parts of sun paths, say the time parts. So as you can see from in this particular sun path, these are the timelines. This is 7, 8, 9, 10, 11. The mid one is 12, 1, 2, then this goes 1 p.m., 2 p.m., 3 p.m., 4 p.m., and 5 p.m. Okay. So if we overlay these lines over the irradiation map, we'll be able to see which exactly are the times which you want to shade on. So the first thing which you check is the, as you can see on this one, you check for the high intensity radiation. So more than 20 is generally considered more than 15 is generally considered high. So you want to shade those particular irradiation, and then you put your those lines over the top of it, just overlay the sun path on the top of this, and you can see which hours you want to shade from. So when you overlay a sun path over this particular monsoon months, you'll be able to see that generally that happens. You will be able to, the shading would be required for 11 to 2 p.m. It would start somewhere around here, and then 2 p.m. would come somewhere around here. So I think that's the way we'll be able to check. However,
Yeah.
I checked that, and you could also look into this on Andromash tool. So Andromash to, I don't know, should I quickly share and show them how to check for the
Sure,
same?
yeah, definitely. Yeah.
Hmm?
That's good.
Okay,
Yeah.
all right. So while we are doing this, I quickly figured out the location, and you'll be able to see the sun positions across the. Okay, this is, and Yashima, can you see my screen?
Yes.
Okay, perfect. All right. So this is a quick tool. This is called Andrew Marsh tool. This is for our listeners. This is a very simple tool to look into. This will give you the exact hour of the day. Okay, and what is the azimuth as well as altitude for sun position during that time of the day. So say if you want to shade for this based here, you'll be able to check the time. Okay, and here will be date of the year, so which month. So say if you want to say shade in April, and so as per the irradiation graphs, we already saw that what are the we want to shade around 1 p.m, right? 12 p.m, we want to start shading from 10. So based on this tool, we'll be able to see that what should be the azimuth for the shading here. So you'll have to shade at 59.26 if you want to shade from 15th April sun from say 10 a.m. onwards. So yeah, you'll be able to look into something like this in 3D and calculate the angles from this.
Great. Thanks, Mansi. I've also shared the link to this tool. I know we'll get a lot of questions about, how to get this tool. So I've already put in the link in the chat window. You can go there. There's a web application also, I think. And am I right, Mansi? There's a web application.
This is a web application, yes.
This is a web application. Yeah. All right. Great.
Ashima, this for the attendees, the Andrew Marsh tool is also covered under additional resources in the self-learning modules. So please take a look at self-learning modules, and you learn about a lot of the tools that get covered in the webinars.
Yeah. Thanks, Prasad. All right. Another question. PC, this one's for you. Can we use DesignBuilder's ability for naturally ventilated building to generate accurate results? Also, what is CFD?
Okay. Yeah. So two answers to that. We have a saying in energy simulation. I'm sure it's there in other things as well. If you put garbage in, you will get garbage out. Okay. So when you say accurate results, what are we looking for? When we are modeling an hourly energy simulation, you are putting in some assumptions on how you think the building will be working. And DesignBuilder will give you an answer for that. But if your actual building doesn't work like that, or when you finally construct it, that's not how it was constructed as you analyzed, then your results will not match. So it's really about being able, that's why we say that, you're doing a design, you're taking the best assumptions that you can, and you're trying to answer a question. And if those assumptions are not right, then your answers won't be right. So as long as you are aware of that, that's good. Now, CFD is computational fluid dynamics. Okay, it's a very complex amount there's a lot of computation going on to generate certain pictures. I'm going to see whether any of my presentations actually has got a CFD in there. No, I took it off, sorry. But essentially, if you look at, weather data, weather satellites and the pictures that they show you on when a weather forecaster shows you, that is multiple CFD runs. That's a supercomputer doing CFD runs every half an hour, 1 hour, 3 hours. We can do in energy simulation, our computers are much smaller. We're using little laptops. So you can choose 1 hour sometime and you can do a run, and it tells you what is the potential air streams, temperatures, and velocities within one particular space. So you can take a slice either in the vertical direction or in the horizontal direction, and it will show you those sorts of things. Okay, it's not very good for what happens across the year. it's very good. Well, it's reasonably good for what happens at one particular hour. Okay. I think I can leave it there.
Yeah, thanks, PC. All right, another question. Considering climate change, how can we check if a design will be net zero in future? Are there any future weather data files available? PC, would you like to answer that one?
That's a very good question too. In that climate one or climatebuilding.org that Mansi was telling us about, there are many climate files which are using data up to, I believe, the latest set of data is from 2007 to 2021. So it's pretty recent sort of data, and they've taken reference weather files from that. If you look around, there are research organizations, and I can't tell you the names directly. Mansi, you might be able to say that, of people who are putting out future weather files, as they are called, and they are for different RCPs. So you can pick one of those weather files, and you can actually run your building through that, and you can get a 2030, a 2050, a 2070 weather files. I know these three time intervals are available. Mansi, do you have anything more you want to say on that?
Yeah, so future weather files is also, in our field, we have to look into climate predictions and the future proofing the buildings for the same. So yeah, ASHRAE are doing this. ASHRAE specifically, and then there are a couple other organizations across the US and UK and then these synthetic weather files are available for a lot of locations in US and UK. However, I would like to say that for India, there is no set of data set which is readily available, which can be used. However, there are ways to develop these synthetic weather file data. So there are papers which talks about it, and based on that, we have to derive. Yeah.
Yeah, thanks, Mansi.
Actually,
So that would be, yeah, please, Prasad.
Yeah, so like Mansi said, the data for India for future weather files is not easily available. There isn't anything published. You can generate the data yourself if you have access to the scripts and the codes that other researchers have written. One of the easier ones to access and work with is available from University of Southampton. And you could look into that, and they have some Excel tools that generate the data based on the data that you would input in. So you can take a look at that.
Sure, thanks, Prasad. All right, another question we have is, our project partner has registered in the program, but I'm unable to see them in the project partner section. Prasad, would you like to answer that question?
Just write to Uday at solardecathlon.india.in on this one.
Yeah, okay. All right, next question. Can you please explain how to interpret values and graphical scale range provided in the irradiation map? Mansi, I think that one's for you. You're on mute.
Yeah. So, all right, I think I covered that one, but I can do that. Yeah, sure.
Also, another question about irradiation is how to check time in the irradiation chart that you showed. So I think you can cover both bits.
I think I just covered those in my
okay.
Yeah, so the way I said that you could overlay the irradiation charts. You can overlay the sun path over the irradiation chart, and then you'll be able to figure that out. I showed that 5 minutes back.
Yeah.
So.
Yeah. All right. Okay, another question. Does site contour play a major role in climate analysis? Can you explain how? Mansi, have you ever worked on a contoured project in the hills or something?
I haven't yet. I haven't gotten a chance to work on a project which was on hilly terrain, but I would like to believe so that the direction of the terrain and the direction of the wind and the irradiation would have an impact. So the overall microclimate of the particular place would have an impact because of the terrain. So yeah, so that's
all right. Yeah, thanks. One last question that we have today is, what value should be given for number of design iterations to get design builder internal CFD results, which are reliable and quick? Does it vary with size of the project model? PC?
It's a wonderful question. Look, typically in Design Builder, the default is set for, I think, 5 or 2000 iterations. So, but if it doesn't converge within that 2000 iterations, you need to kind of pick another initial starting point and do it again. CFD is a very complex business, and reliable outputs from that requires some experience. If you're, even when it's trying to converge, if you find that it's kind of going positive and negative and going positive and negative and doing strange kind of things, best to stop it and find another place and start again. If you don't get a kind of a smooth curve towards the solution, you should really start again. Probably best to check with somebody who has some experience in CFD. And I would suggest that for what you are doing, you probably don't need CFD. For most things, you wouldn't need that. Now, I'm just going to share my screen because the previous question on contours, okay? Here's a project that we did. As you can see, it's kind of set into a cliff face. We found some contour maps, and this is called a ground block, this green thing. So you can set your building into contours if you've got a really steep side. Any earthworks, like for example, this one, these walls are going to see ground heat transfer. So what happens then is, as Mansi was explaining, 4 meters deep into the earth, the temperature is very stable, doesn't move around much, and the model needs to know that, okay? In Design Builder, there is a specific model called Kiva, K-I-V-A. You can just search the help, which is very easy to find. If you just search for Design Builder version 7 help, you'll find it. Here it is. And if you search for Kiva, it'll show you how this special ground coupling model works. Now, you really only need to use that when you have a building which has got a large ground coupling, okay? So suppose you've got a single floor building or a building which has got 2 floors or 3 floors, then you need to worry about the coupling. If you've got a basement underneath your building, you don't need to worry about ground coupling because your basement is not conditioned, and then above that is where the conditioning is. So your first floor is your first conditioned floor is decoupled from the earth. Only when you have a slab on grade kind of building which is a large ground floor do you need to really worry about the ground coupling. So just be mindful of that. Every time you add layers on, the model takes longer to run, but certainly there is some accuracy possible, increase in accuracy possible with that.
Great, thanks, PC. Another couple of Design Builder related questions have come in. I'll take them one by one. One is, does Design Builder show payback year for the building?
Feedback, what, sorry?
Payback.
Payback.
I think it's about
oh,
return
yes.
on investment.
Yeah. Look, I believe there is a cost module where you can put dollars in there. I haven't bothered to use that, but it's available. And also, from what I understand, there are some webinars where you can look at. I'm just trying to find. Yeah, see, there is a design optimization webinar, okay, where it talks about cost benefit simulations using Design Builder. You're very welcome to watch that and see how it works. Just remember, all the costing for materials are in GBP, Great British Pounds. And I think we were talking about possibly getting a materials database for Indian materials which you could replace some of the numbers with and get some outputs from there. But right now, it's all GBP. So, be careful when you use those sorts of optimizations.
Also, PC, the costs for those materials are not costs for India. So if there's any payback in there, that won't make sense for our context, right?
Absolutely, absolutely.
All right. Another question: if we can link Revit and DesignBuilder files, is that possible, PC?
Yes, there is a plugin for Revit. I think if you go to the download section, let me have a look. There is actually a plugin for Revit that you will find here. DesignBuilder add-in for Revit. Okay. Now, I will warn you that if the architectural Revit model is not the kind of model that you need for energy analysis, you will lose a wall or lose a room or lose a floor. So be very careful when you use that. If it may be required for you to go and make some modifications on the Revit model before you try to import it. As far as possible in my office, okay, and that's because we are very we do very complicated buildings, but we like to draw the model from scratch, and there's a reason for that. We always find that those models are much lighter, they run much faster, you are very confident about what you put into the model, and the analysis we can be really confident about. Having said that, I won't discourage you from trying it out. Please do. But just be aware that you may need to actually go and modify the Revit model before you can import it. And one of the things to really think about is that when you're doing an energy analysis, an energy simulation, every zone has got at least 6 surfaces. They may be virtual, they may not be real, but you have a have a ceiling, you have a floor, you have 4 walls at least, okay? And if the Revit model doesn't have that, but has got a really free-flowing sort of architectural model, then when you import it, you may not be that successful. So be careful with that. It's the holy grail. Everybody talks about BIM. We haven't reached it yet. When we do, I'll be out of a job. But anyway.
All right. And one last question. I think this is partly answered, but I'll just take it up again. Is the data that we get on most weather sites give the climate of an overall city? But what if we have a huge building mass near our site that kind of changes the wind direction and our sun analysis? What do we do in that case? PC, Mansi, I'd like you to give your thoughts on this one by one. PC, if you can go first.
Okay. Look, the solar analysis is easy. Okay. In DesignBuilder, you can model any surrounding buildings as component blocks, and it's very simple. It will allow you to do that. Okay. The other one is a bit more difficult because what you're talking about is microclimatic effects. And the only way to reliably do that is actually to measure what the site weather, temperatures and wind speeds and all are, and create a specific weather file for that location. Mansi, if you want to add something on that.
I agree actually, PC, with you on this one. Creating a microclimatic weather file is trickier because you'll have to have a weather station and then you'll have to record it across the year, couple of years to get the reliable data set. So yeah, but it's easier to do it over, say, for irradiation studies or when we are doing for daylighting analysis. Having said that, so microclimate would have an impact on that would have an impact on overall EPI. But however, if say simulation is used as a tool to give out suggestions in terms of or take the strategic for strategic solutions, or looking for say which U values to choose from, or exactly what kind of shading should be provided for. So for all of that, I think I mean, one can get away with without doing any sort of microclimate analysis. So if I think that should be fine, not even doing a microclimatic analysis and going to the details of it is all right. For, informed decision making, the climate weather data file which is available should be good to use.
Okay,
thanks,
so
Mansi.
if I can quickly show you, what I've done is I have made I did it very quickly, so apologies for making it look really strange, but I just put a 20-meter high building on the south side, which is where the sun comes from. Okay, so if I then look at what's happening at the building behind, what you'll find is that in the winter, so if I make it say December, and I do some early morning, say, okay, even now you can see this is now 10 o'clock in the morning. You can see that that building is now shading this building. Can you see that? Right? Yep. So the sun is penetrating in this area, but it is being shaded over there. And as you move the sun around, you can actually see what goes on. So in the summer, in April already, this 20-meter high building doesn't impact the building behind. So you can, that's quite easy to model in DesignBuilder, and of course any other software like that.
Yep. Thanks, PC. All right. I think those were the questions that we've got so far, and we are at the end of our session today. And I hope our participants can now begin with their climate analysis bit for their deliverable 1 submission after this discussion today. Thank you so much once again, PC and Mansi, for your insights and sharing your experience on the climate analysis piece. And once again, I would like to thank our supporters, DesignBuilder, as well as Climate Works Foundation for their support for Solar Decathlon India. Thank you everyone for joining in, and we will see you all soon for another webinar that will happen actually after deliverable 1. So good luck for your submissions. Thank you. Bye.
Thank you.
Good night. Bye.
Bye. Good night.